Everyone, my name is Rick Drucker and I'm the Business Development Specialist for Lesman's Industrial Hygiene and Safety business. Thank you all for joining us today for today's webinar on gas detector tube sampling, advantages, and applications. It's certainly not uncommon for us to be asked when gas detection tubes are appropriate versus other gas detection methods. And today's presentation will discuss advantages, applications, limitations, ease of use, choosing the right tube, and how the tubes can support your overall industrial hygiene program. Today's speaker is Aaron Apostolico. Aaron's a certified industrial hygienist and product applications and research manager with Sensidyne. He's responsible for Sensidyne's corporate IH program and managing the product applications across business. He also provides technical support for the product lines to the entire global marketplace. Aaron is well versed in the practice of industrial hygiene and environmental health and safety. His specific knowledge includes evaluation of safety hazards, accident investigation, risk analysis, safety program audits, safety training, compliance review, and development and implementation of safety programs. He is proficient in industrial hygiene air monitoring with evaluation of field test results and management recommendations. Aaron received his BS degree from Rutgers University in environmental science and attended University of South Florida's College of Public Health for graduate studies in occupational health and safety. He currently holds professional designations as a CIH, a certified safety professional, and as a certified indoor environmental consultant. As always, we welcome Aaron back as a speaker and always appreciate his expertise. Just a little housekeeping. During the seminar, we do need to mute all the microphones, so please type any questions that you have in the GoToTool question box, and we'll either try to weave them in if we can, or if not, we will certainly get to them in the Q&A section at the end. So with that, I'd like to pass it over to Aaron.
Thank you very much, Rick. I really appreciate the introduction. I hope there's a little something for everyone in this presentation. I'm hoping also that I can use a little bit of my background. I spent many years in the consulting side and in industry as in-house health and safety, utilizing both air sampling equipment as well as gas detector tubes to really give myself the most flexibility of having a complete industrial hygiene program. So I'm going to talk a little bit about some of my past experiences, as well as a little bit of the product and the product line that Sensidyne offers to show how it can best be utilized within your individual programs. So I wanted to start by going over a few objectives. First, I wanted to talk a little bit about the application side and really stress, you don't know what you don't know when it comes to hazards and risks in the workplace. And one of the ways that you can determine or perform some of these initial risk assessments is by using gas detector tubes. Again, it can be a screening tool used for detecting process leaks. It's commonly used on the health side to assess if toxic gases that are present are above a threshold level. And by threshold, these can be levels that are immediately dangerous to life and health. They can be OSHA-defined ceiling limits or an OSHA short-term exposure limit, or following one of the ACGIH TLV guidelines. Now, if concentrations of flammable materials exceed a lower flammability limit, again, you can use gas detector tubes if they're within the correct range for that application. Additionally, you could determine if engineering controls are effective, and I'll talk a little bit more about that as we move forward with the presentation. Another objective is to understand, what challenges are there out there within individual IH programs. And, air sampling can be most certainly an effective method, but it can be expensive, time-consuming, and depending on what you're sampling for and the media involved, it can become complex. Now, gas detector tubes are, affordable, they're fast and easy to use, And for screening areas, performing risk assessments, it's a great solution to be part of your program. And then lastly, I really want to impart some knowledge to all of those attending to fully understand how to use a hand pump and detector tube properly. Learning about different techniques to sample from pipes and ducts. So there are certain accessories and certain methodologies we'll cover. Learn how to select the right detector tubes as well as the right detector tube range. And then understand how screening with detector tubes can really be a cost-effective and efficient way to identify both risk and compliance within your workplace. So here we have a little presentation outline for today. I'm going to cover the history of gas detector tubes, how gas detector tubes work, certain advantages of gas detector tubes, really how to choose the right tube based on, what is your purpose for sampling? Are you sampling for health, for safety, for environmental compliance? It could be process related, or it could be emergency response for hazmat identification. We'll talk a little bit about brand component compatibility, as I know that that's a common question that gets asked. And then we'll talk a little bit about some programs that Sensidyne offers, kind of that addresses some brand component compatibility issues. So as we get started, it may be surprising to some of you that the first gas detector tubes were developed in 1919. Now, many of you probably have heard the old adage about the canary in the coal mines. Well, the reason that they would send the canaries down in the coal mines were actually to detect for carbon monoxide. Well, we evolved past that technique in 1919 when these two Harvard professors developed these gas detector tubes specifically to look for carbon monoxide down there. A little bit later on, about 1935, the U.S. Bureau of Mines continued with this kind of protocol, looking for hydrogen sulfide that was prevalent down in underground coal mines. And then the first commercial detector tube systems really appeared in Germany, and these were made by Draeger. And then relatively in line and at the same time, also developed in Japan, made by a company called Kitagawa. And this was shortly after World War II. So talking a little bit about, what is a gas detector tube. These are disposable glass tubes. They're used to identify a targeted gas within a specified measuring range. And the important takeaways are that they're very simple to use and read. They're inexpensive. And that the accuracy, again, it gets you close. It's within the ballpark, but, it's not a precision type of instrument. So you have to have, that knowledge of it and really how to read them properly to get the most accuracy out of them. Sensidyne has been a major player and supplier of these detector tubes in the U.S. since 1983. And we really want to know that detective tubes really are a cost-effective solution. Sensidyne offers more than 350 different gases and vapor substances that can be analyzed with our gas detector tubes. So now we're going to cover a little bit about how gas detector tubes work. So what you see in this side is our AP20S hand pump. So unlike air sampling with air sampling pumps, these are non-motorized. These are a manual pump. This particular pump is a piston style volumetric pump. And the way that it works is there's a cylinder with a known volume inside, and you have this handle that you actually align with the red mark. You'll pull it back. When it locks into the first position, that's set to pull in 50 milliliters. When you pull it all the way back, it's locked in to pull in 100 milliliters of air. Our pump was really designed to be ergonomically friendly. So it's got this non-slip grip, and it's an antibacterial grip too, because we know we take this out into the workplace. So it helps to keep it sanitary. But you're able to grab hold of it and pull back the handle, the charging handle, to really get that accurate every time volume collected. One of the other features of the pump is a flow finish indicator. And what this does is it lets you know when that full air volume has been sampled. So as you have a negative pressure within that space, it pulls this little red flow indicator in, and then when it reaches its neutral pressure, the flow indicator pops out a little bit like a turkey baster. So I wanted to go over the detector tube anatomy. As you see here, you have the glass tube. It is fire sealed at both ends. The first thing you'll see to the left is going to be what looks like a white kind of almost cotton or foam plug. This is typically for removing moisture for relative humidity that might be in the air, because it could impact the reagent in that analyzing layer. Another factor is that sometimes it is actually containing another chemical reagent, which would be a precursor for the reagent that is in the analyzer material. That information usually is specified within the instruction sheets for that specific tube. So again, in the middle, you see the analyzer layer along with the scale for that range for that particular detector tube. After that, again, there's another plug, and that keeps those materials very tightly aligned in that section. And it's important that it actually be very tightly aligned, because once that scale is put in place, you don't want materials moving behind it. So, it is specially designed so that material is very held in place, and that the reagent change is both accurate and consistent across all the tubes. After the plug, again, you'll see a gas flow arrow. This is to help align the detector tube in the correct direction. So as you can imagine, the airflow will be heading from left to right, and then you would plug that far right side into your AP20S hand pump. So this is a basic instruction. I know many of you have taken samples before, but for those that haven't, our hand pump contains a tube tip breaker right adjacent the handle. You would basically twist the detector tube inside the tube tip breaker, and then you'd lean it to the side and it would break off the end of the tube. You would do that to the opposite side. You would then take the tube and, following the direction pointing towards the hand pump, insert that into the end of the hand pump. Then you would align the marks on the lock handle. You'll see a mark on the back end of the hand pump and a mark on the handle. When those two align, it's ready to be pulled out, either halfway for the 50 mil or all the way out to the 100 mil mark. Each detector tube has a weight allotted time. The weight allotted time is there because a chemical reaction is taking place. So once the gas constituent in question comes in contact with the reagent, that's the amount of time required for the reagent to react properly and show the color change. And then lastly, you can remove the tube from the pump after that weighted allot time, and you could read the stain against the scale that's on the tube. I will note that Sensidyne recommends performing a field leak check prior to sampling. You pretty much follow these directions except for step one. You would leave the tube intact, insert the tube, align the handles, pull back the handle all the way to 100 milliliters, and this time you're going to wait 1 minute, and that indicator that I told you before will stay depressed. As long as that red indicator doesn't pop back up after a minute, you have a good seal and leak check performed. Then you can pull out the tube and then start performing these steps. Once you complete the sample and you're ready to read the tube, again, remove it from the pump, and you want to look down at the scale. Ideally, you'll see a normal stain change where it's right even with a specific range mark. However, it's not uncommon that some channeling may occur, and this could be kind of a slanted angle across the tube. If this occurs, you would kind of add, the lower and higher readings and kind of divide that in half. So in this example, you see that it kind of goes from almost like 4.5 to 5.5. So you would add those together and divide by 2, and that's where you get an average of 5. Feathering, on the other hand, is kind of when it goes from a really dark and prominent stain to this kind of light stain. And, it's really recommended that you use the end of the faint stain as the reading. In this particular example, you can kind of see the faint stain going all the way out to around 5.5. So that would be the appropriate reading when you see feathering of that type. So there are certain gas detector tubes. Most gas detector tubes are single tubes where you're going to get 10 tubes in a box. However, there are certain tubes that require a pre-treat. Some require a special additional reaction tube in line with the detector tube. So if there was a triple series tube, for example, they would provide 5 gas detector tubes that are the tubes that you would read, and then they would have 2 different pre-treat tubes involved. And that's in order to get the chemical reaction necessary for the final detector tube reagent to react properly and change color. So one of the things that you'll see with a twin or triple series box of tubes is there'll be a kind of a rubber tube section that you will use to connect the pre-treat tubes in line with the detector tube. And again, the pre-treat tubes will always go on the opposite side of where the arrow is pointing. So upstream from the sampling pump and upstream from that final detector tube. There are times when a detector tube might not be in the unit of measurement that you need for compliance or for your testing parameters. So for those that aren't aware, when you see a concentration of 1%, 1% is equivalent of 10,000 parts per million. To get from a ppm scale to a milligrams per liter scale, you would use this formula where you multiply that reading in parts per million times the molecular weight of that gas in question, and you would divide it by 24,450. And of course, you can invert that formula if you were going the opposite direction from milligrams per liter to parts per million. So now I want to talk about some real advantages of utilizing, detector tubes. And, first and foremost, people go to it because it's a low-cost screening tool, and, it's has enough precision that it can offer, direct reading for over 350 measurements of gases and vapors. The detector tubes are simple and easy to use. They're designed really for non-technical users and require minimum amount of training. Sensidyne tubes specifically are high quality and highly reliable. We make one of the best in class tubes that are on the market. And I say this because not all tubes are held equal. Different manufacturers and their quality and their repeatability are not necessarily at the same standard, which is why, we can say that we really meet that best in class gas detector tube offering. Compared with performing, air sampling using a traditional air sampling, motorized pump and sample media and sending it off to the lab, the cost of an individual direct read sample is very low. We also have to compare it to some of the newer technologies that are on the market. So more recently, there are single gas meters and electrochemical sensors, but they have their limitations as well. And when you compare gas detector tubes against some of these, handheld gas meters, one of the things you have to remember is obviously the cost of the gas meter is significantly more. You have to maintain it. You have to change out the gas sensors periodically. A lot of times you have to calibrate and perform bump testing on those samples, and they have to be charged and ready for use when you need them. Whereas when you use a gas detector tube, most of them have a 2-year shelf life. You can keep them on hand, during that entire window, and pull it out. You don't have to calibrate it. You can perform your leak check on your pump. You can perform a reading and get a reliable result right then and there. It can provide a clear indication of concentration level based on that length of stain on the glass tube. And again, 90% of tubes are either 1 or 2 strokes maximum, whereas with some other tube manufacturers and pump types, they could require multiple hand pump cycles or strokes. So really, we want to make this both fast, easy to use, reliable, and timely for use. So next, I really want to talk about how to choose the right detector tube. It's important to really understand what is my purpose of sampling, and based on my purpose of sampling, I will choose the correct tube. And I will note that we have detector tubes for the same parameter, for example, hydrogen sulfide, water vapor, and several others, where there could be anywhere from 3 to 5 tubes that measure that particular gas. And the difference between them would be the scaling and the range that they depict for that particular gas detector tube. And the basis for determining what is my range is, what am I sampling for? Am I looking for health reasons, where I'm going to look at OSHA threshold levels and ACJIH threshold levels? There I'm primarily looking at toxicity, corrosivity, irritation, carcinogenicity. So, knowing that those levels could be very different than sampling for other safety parameters, maybe even of that same chemical. If I'm looking for safety, again, we have gas detector tubes that might help indicate flammability. They're often used for confined space entry, as well as for compressed breathing air, testing and making sure your compressed breathing air is not introducing contaminants, oil mist, water vapor into the breathing air of those using that system. I will note, again, even with modern confined space handheld meters, they have limitations in both toxic gas sensors that can be utilized in them, whereas there's not nearly as many toxic gas sensors as there are gas detector tubes that are offered. So a lot of times gas detector tubes are used to help supplement a confined space entry program, not necessarily to be used solely in place of it. As far as environmental testing, again, they're commonly used for testing stacks and scrubbers, as well as, I would say rogue emissions. Those values and again, concentration levels that you're looking for could be very different than that of your health and safety. And for that reason, again, you might want to look at choosing one detector tube range over another. They're also commonly used in processes. So you might have gas in pipes and not necessarily meaning to get out of pipes, but you still want to look at the concentration within it. Well, we have ways of performing sampling for gases contained in pipes, and I'll talk about that a little bit more. Again, that gas may be either a contaminant or it could be an additive to the gas stream, something you want to be there, but want to know that specific concentration within the gas stream. And then lastly, hazmat identification. This is when you really don't know what's present. It's most commonly used during emergency response. And we sell a specific emergency response hazmat kit where we have a special 2-tube process that you can really utilize to determine, what family of gases. It's more of a qualitative test that gets you to the right contaminants, that then you could use one of our other many gas tubes to get a quantitative measurement. So talking about some tube applications, one of the bigger applications is within the oil and gas market. We know that our tubes are often used in refineries. Probably one of the more prevalent tubes used in refineries are hydrogen sulfide tubes. And again, we know that hydrogen sulfide is both toxic as well as corrosive. It can be used, again, to look at both processes as well as environmental, as well as health and safety. So again, depending on what your specific application is within that oil and gas market, you might use a variety of the different tubes for that particular contaminant. So natural gas is another one where we might be looking for a contaminant within the natural gas. Items such as water vapor is very common. You're not really sampling within the actual inline stream of gas within the pipeline. So what you really need to do is sample from a sample control valve. And we actually have a pipeline sampling kit, kind of shown on the picture to the right, where you attach it to a valve system. And what it does is it pushes the air or the gas stream up into that spherical container, and there's holes at the top, so it's vented. And the purpose of that is, in order to perform a proper sample and get the proper volume, your gases must be at a neutral pressure. So you really can't sample from a positive or negatively pressurized stack or pipeline. So using this system, it allows you to sample that gas stream really at a neutral pressure state and directly into the tube to ensure that you get that full 100 or 50 milliliters pulled into your detector tube. Grab sampling. This is another common application within many industries, and you would want to do this, in a couple different ways. So, most of the samples we pull with a hand pump is really just a grab sample in the field. Another way to perform that might be to not expose an individual or health and safety professional. And again, we make pumps and we sell, gas sample bags where you can actually set it up and program it to sample within a very hazardous area. It'll collect it in the bag, and then once it's safe to go in, you can actually go in, retrieve the bag, or use respiratory protection to go and retrieve the bag, bring the bag back out to a safe area, and then connect tubing to it and pull your sample into your gas detector tube to get a direct reading and determine whether concentrations are above that threshold level, whether it's ceiling, short-term exposure level, or IDLH concentration. Leak checking is probably one of the most common uses of gas detector tubes in the industry, and mostly where either a fixed gas detection system and or handheld portables can't meet the needs of the job. And as I mentioned, there's far more gas detector tube options for toxic gases than there are electrochemical sensors in handheld devices. So for that reason, it's still commonly used. Also, it'll help locate more specifically where a leak may be occurring. In LP gas, as most of you know, if you've ever smelled LP gas, you're not actually smelling the liquid propane. What you're smelling is a mercaptan that is added to the propane, obviously as a safety precaution. So this is one of those instances where we have specific tubes that can measure mercaptan. So I'm just using this as an example. Sometimes certain chemicals are added within a system, and you want to make sure that it's at the appropriate level and concentration within another gas stream. So the use of these gas detector tubes can help determine that concentration level. Sampling for hot gases. For those of you who have been around gas detector tubes for quite some time, this may be something that's new to you, but we actually have an accessory called a hot probe. Now, most gas detector tubes have temperature specifications on them. Typically, they're from 0 to 40 degrees Celsius, which is 32 to 104 degrees Fahrenheit. And anything that's hotter than that could result in, incorrect results. So with using our hot probe, which is our part number 7013602, it's really designed to bring the gas through this foil plate, which is acting as a heat exchanger. And what that does is it cools the gas prior to getting to the gas detector tube, bringing it down within that temperature specification range for the tube. So as you see here, basically the accessory consists of a stainless steel tube with these cooling fins. It acts as a heat exchanger, and really the job is to bring down the gas level. It does require that the probe itself be in a cooler environment than, of course, those elevated temperatures. So tube selection guide. So once you've performed, or if you know what risks you have at your facility, you can go to our tube selection guide. Again, this is something that's offered and available on the Sensidyne website. It can also be offered through our host, Lesman. This will tell you, again, based on what gas you're looking to sample, whether it's a known process chemical, a byproduct of a process, it could be a product of decomposition, things like vehicle exhaust or compressed air. Once you know what gases you're looking for, you would go to this selection guide. It'll give you a little bit of information about what the TLV TWA is. I will note that this is a little bit dated because the TLV TWAs do get updated periodically, but it'll generally give you an idea of, the threshold level for the ACGIH TLV. Again, if you were looking for sampling for environmental conditions, you might want to look at EPA levels. And then, of course, for compliance, you would want to look at the most recent OSHA level to base this on. But you can see next to that, it'll give you a couple different tube options. It'll tell you what the measuring range is for that. It'll also tell you the amount of strokes that are required, and then some conditions for both testing or utilizing that particular tube type. So I mentioned, the measuring range. This is a critical aspect. You want to know, am I trying to meet the permissible exposure limit? This is an OSHA level. Am I trying to reach the ACGIH TLV, which might be less than the OSHA limit? Am I looking at a short-term exposure limit? This is usually a 15-minute exposure limit that you don't want exceeded. And of course, a ceiling limit is a limit that you don't want to exceed at any time. And then IDLH, which is usually a limit that could literally prevent you from being able to safely escape from if exposed to that limit. So if you know those limits, again, you want to make sure that the measuring range is within your range of the target limit that you're sampling for. Sensidyne has also put together a tube industry guide. So for anyone who is looking to say what types of products are available within my industry, again, this is available on our website, can also be made through our host Lesman. And from this document, what you can do is look in your specific industry, look at a specific process type or kind of a subtopic within that industry, and see what chemicals are predominantly used within that field. And then once you see that, you can see our offerings, which could include anything from pumps, fixed gas detectors, and of course, gas detection tubes. We also offer our tube handbook. We have this in both digital and printed formats. So if you do know your chemical, then you can use this to actually determine what tube number is needed. You can also see in here information about detectable limits, the sampling time, as I mentioned. In this particular slide, you'll see that it's for ethyl mercaptan. When you see the sampling time of 1 minute per 1 pump stroke, you would pull that pump stroke and you would wait 1 full minute before reading that tube. One of the things I also want to point out is on these instruction sheets, it'll tell you about interference and cross sensitivities. You know, this is important to know, not only what the result is, but is my result being impacted by other chemical gases that may be present? This also applies, you know, similarly with electrochemical sensors. So if you were using, you know, a handheld monitor, even in like areas like confined spaces, if there were interfering gases or cross sensitivities present, you may want to get a gas detector tube that would detect that interfering or cross sensitivity compound. So I want to talk about inter-brand compatibility. This is a common topic that does come up. You know, mixing brand components is not recommended. When the gas detector tubes are calibrated and, you know, they go through a quality assurance protocol, they are calibrated using the specific hand pumps that they are meant for within the brand. So people say, you know, can I use your, you know, gas detector tube in a Draeger hand pump? For 2 reasons, the answer is no. One, the Draeger tubes, for example, are a different diameter, and using a Sensidyne tube in a Draeger hand pump, you wouldn't necessarily get a tight seal. And then, of course, that could impact the air being pulled in, which could impact your flow range. So it's really recommended that you stick within a branding when you are collecting detector tubes, that you use the correct branded hand pump, manufacturer's hand pump, for the detector tubes that you are utilizing. Some brands are made of higher quality standards than others. You know, note that too, that even if it did fit tightly, that because that brand might not hold the same quality standard, that it could, you know, significantly impact that reading. For this reason, Sensidyne offers a pump swap program, and I'll talk about that momentarily, which allows you to, again, consolidate if you need to. If you have a different company's pump, but you want to use our tubes, again, if you buy, I think it's a set of 12 boxes of tubes, if you know you have a lot of sampling to do, we can offer, you know, a pump as part of our pump swap program. Superior quality control. You know, this is something that, you know, the Sensidyne tubes can really stand out against other manufacturers. We perform lot code traceability. We retain samples at our manufacturing facility. All components of the detector tubes are all code traceable. We have individual lot calibration with national standards traceability. The manufacturing process is under an ISO 9001 quality management program. And our tubes, as opposed to some manufacturers, are precision machine manufactured to get optimum reproducibility. And this is really important because for some tubes, and I've seen, you know, even scales be slightly off with some of the competitor tubes that are on the market, you really want to have precision repeatability within the sampling process. And that's something that you definitely find within our Sensidyne tubes that may not be present in some other manufactured tubes. Again, here is that side for our pump swap program. Again, if you buy 12 boxes of tubes and trade in a competitor's pump, you can receive the Sensidyne AP20S pump kit for free. Again, you would want to contact Lesman to find out a little bit more about that program, and they're happy to assist you with that information. We, as the manufacturer, are very competent and confident in our building and design of our hand pump, where each of our AP20S hand pumps has a full lifetime warranty. So if for whatever reason it breaks or it's not holding its seal, again, send it back through Lesman or to our service center, and we will repair it under full warranty. I talked a little bit earlier about our hazmat kits, and these kits are really meant for emergency responders, although we've heard that some facilities have their own emergency hazmat teams within their facility. It's nice to keep this handy. This kit comes with everything from an extension probe that can be used and lowered down into a confined space. It contains this hazmat chart. So I mentioned that there are 2 specific tubes that are utilized to really determine what chemical family is present. And once you know the chemical family that's present, again, you can further analyze the tube to determine from a qualitative state to a quantitative value by using one of the other tubes that you would have available in your hazmat kit. So again, you would have the 2 boxes of tubes used for the qualitative analysis, and then several boxes of very common gas detector tubes that would be used to get a quantitative result. So here you can see those 2 tubes on that color chart. It's tube number 186B. This really determines your organic gases that could be present. And then the tube 131 is really used for determining inorganic gases. And you can see that there's 5 different sections within that tube, that each one of those sections, depending on the color stain change for that section, will indicate a different inorganic gas group. And then similarly on the 186B for the organic gases, depending on the color change within that section, you would be able to determine what organic gases are present in that unknown gas stream. For our hazmat kits, we've set up a 2-year tube service contract. So this is available, under a specific part number. We know that you have to keep these systems up to date, and we know that tubes, depending on which tubes you have present in your system, have different expiration dates on them. So if you purchase into this system, then we will send you those tubes at those intervals to make sure that your tubes are always in within the expiration time frame for that shelf life. So I want to leave you with just why you can use Sensidyne tubes. Again, we offer outstanding customer service, the finest technical and application support in the industry, excellent on-time delivery. We keep our detector tubes, again, available here, so it's very fast turnaround when you need them. Full line quality product. We keep them refrigerated here to make sure that they have the best shelf life when you get them. It's also important that when you get them, if not in use, again, to prolong and preserve that shelf life and the integrity of the tube, to keep them refrigerated until you need them. And then, of course, our tubes, unlike some other tubes, are used in a shatterproof casing. That way they do not break in your hands when you are trying to break off the 2 ends. And at this point, I would like to open it up. If there are any questions, please submit them to our host, Rick, and he will present them to me, and hopefully I can get them answered today.
Thanks, Aaron. Regarding, everybody seems a little bit interested in the expiration date, which is, such a common question that I ask my wife now about all the food in our fridge too. But how important is the expiration date in terms of that cutoff, and if they could still be used after that?
So again, if you kept it refrigerated, the degradation is definitely much slower. We try to look at it as a worst case scenario. So our chemists, do tell us to, recommend that you stay within the allotted expiration date. If you wanted to keep them around because you have them purchased and you wanted to look at it as kind of a qualitative test, as more of a quantitative test, maybe you can still use it. But once those reagents degrade, the accuracy range is diminished. So the reading that you get if a reagent has degraded will change that length of color stain. So if you're just looking for something that might be a go no go, it might be acceptable to be past that range. But I can tell you, if you're really looking to do something to see if you're in compliance, you really want to be within that specified time range that's stamped on each of the boxes.
Thanks. Kind of related to that is a question of, do you have to refrigerate the tubes after receiving them?
You don't. I can tell you that, it preserves it longer. So for those individuals that don't, I would say, commonly use the detector tubes or might use them very infrequently, I would recommend, keeping them in a dry, they are sealed, but in a cool place. You wouldn't want them sitting out in the sun. I don't recommend, keeping them in your vehicle for extended periods of time. If you know that you're going to be using them, within the first month of receiving it, then sure, keeping it available in your vehicle is a common practice. But if you're going to be, exposing them to higher temperatures for a prolonged amount of times, just know that that can accelerate the degradation of the reagent.
Thank you. I've got a question here. While someone understands that Draeger won't work with your tubes, but will another manufacturer's piston pump work?
So work and be accurate are different things. So functionally, it may pull in that allotted volume, but I would say that each of the hand pumps, the way that it pulls in that volume and the time it takes to pull in that volume might be slightly different, which could impact the way that the color stain is produced. So this is why we really recommend staying in brand, because that detector tube is specifically calibrated based on the manufacturer's hand pump. So when you start looking at that, using cross-compatible piston pumps, for example, that it might fit, it might work with functionally, the actual results could be impacted by using a mismatched brand.
Okay. That asker particularly questioned about Honeywell. And in the next one was asking about, which I think you just answered, but Kitagawa and Gas Tech and so forth. So I think that you answered all of that.
Very similar in size. Those particular ones are similar in size. Draeger has a tube that's slightly bigger, and there, as I mentioned, the issue is compatibility with the fit and leak. But in tubes that are similar size, the issue is more along, the manufacturer calibrates with their hand pump, and the way that it pulls in air, even though it's the same piston style, might be slightly different from one device to the next.
Another question that we've got over here is, what is the proper way to document tube readings?
Sure. I can tell you, when I was a consultant, it was very important when I went out to the field that, I had very good notes. And, since you're not data logging, it's a real-time instrument, I would keep a camera with me. Of course, I'll age myself a little bit. I didn't have a cell phone with a camera on it back when I did it, 20 years ago when I first entered the industry. But nowadays cell phone cameras are so common. After you wait the 1 minute allotted time, I usually take a picture of the tube with the color stain at the range as close as possible so I can read it. And I use that as my supplemental documentation in my reporting. And of course, I usually have a field log specifically where I would list, what detector or tube it was. And I'd want to record down some of the environmental conditions. As I mentioned before, you have specified temperature ranges. I will note that depending on what detector tube you are using, you might have to do a correction, even though it's within that specified range for the temperature that's present. For example, if the range was from 0 to 40 degrees Celsius and it was, let's just say 5 degrees Celsius, certain tubes would have a correction factor that you would need to utilize, where you would take the reading that you would see on the detector tube and multiply it by this correction factor. So in those particular cases, in addition to having your gas detector tube and hand pump, you might also have to know what the temperature of that gas stream is. And in doing so, you would want to record that down, as well as the correction factor that would be utilized, which you would find in the instruction sheet that comes with the box of tubes. So you would want to make sure that you have all of this information, again, put together and then documented. And if you can accompany that with a picture of the tube, that's the best management practice.
Awesome, thank you. Last question I currently have is just questioning the plus or minus 25% accuracy. Can you go into a little bit more depth about, being 25%?
Sure. So, that has to do with multiple factors, and that plus or minus 25% became kind of an industry standard. It came out of NIOSH, I don't know, 30 some years ago, quite a while back. That being said, when our tubes are tested at the time of manufactured, they're much more tight. I mean, when they're calibrated on a scale where they're within, 1-2%. So we're able to get much more accurate results when we're looking at these, in factory conditions, using the hand pump, testing it against a very known test gas. Where the plus or minus 25% usually comes in is the end user's interpretation. So it's because, they surveyed, 20 people, and it may be more, I'm speculating the number of people, but they surveyed a set amount of people and they asked them, hey, all of you read the same tube in this picture and tell me what you see as the result. And you would see that people would read it. And remember, I showed you that a lot of times it's not necessarily clear cut if there was channeling that occurred or feathering occurred, that people's answers were with plus or minus 25% of each other. That's not necessarily 25% of the range of gas. They were within plus or minus 25% of each other. So you reading it and me reading it, again, could differ by, depending on what the scale is, several parts per million or milligrams per liter, just based on how it was feathered, at the time that the sample was taken. So that's really why they give that wide range of plus or minus 25%. If it is, a good sample, it's easy to read. Most certainly the accuracy can be much, much better than plus or minus 25%.
Awesome and interesting. So that's the end of the questions that I've got at the moment. So Aaron, as always, thank you. It's always very informative and we really appreciate you being with us here. If anybody has any specific questions, as always, my direct line is 630-757-1755, and on the screen is mine as well as Aaron's email. And in addition, if you'd like to know about other technologies we support, all of our webinars are posted on our website, lesman.com, and on Lesman Instruments Company YouTube channel. And if there's any additional topics that you'd like to see covered in a webinar, we have a lot of access to different products and product specialists. So if you want to email me and let me know what you'd like to see covered, we can certainly arrange that as well. And finally, just as a note to our attendees who are listening, be on the lookout. As you may know, Sensidyne has recently released the new GoCal Pro calibrators, and we're fortunate enough to have a webinar coming up on those as well. So please take a look at your invitations that may be coming. And I'm not seeing any other questions. So at this stage, I'd like to make sure we stay within our time limit, and I will conclude the presentation. Thank you all for being with us.
Rick, sorry to interrupt, but I see one question that just popped in about storing tubes in a freezer.
Oh, Aaron?
Yeah, so I wouldn't recommend storing them in a freezer. Refrigerator is better. Getting it down to a below freezing point is not recommended. So actually, I would recommend against that, and highly recommend storing it in a refrigerator as opposed to a freezer.
Thank you. John, there's all I see, unless I'm on any kind of a delay. So if nobody is seeing any other questions, again, thank you all for your time. We really do appreciate it. And please reach out if there's any questions we can answer. Thank you again.
Thank you all.
Thanks, Rick. Thanks, Aaron.